So using the equations that we get for a circle, we can test to see that or whether or not a point that they give us is on that circle. So you just have to remember the form for the equation of a circle: x minus h squared plus y minus k squared equals r squared. HK is the center, r is the radius, so when we go through looking at this first example, if it is centered at the origin, that means 0, 0, and the circle contains the point 3 comma square root of 7. We don't know the equation of the circle yet because we don't know the radius. So we can find the radius, or we can just plug everything we know into the equation of a circle, and that will give us the radius also. So you can find the radius by doing distance formula. The distance from the center to the point will be the radius. So from the center, 0, 0 to 3 comma square root of 7, that's going to be our radius. So distance formula with these 2 points. Remember, distance formula is x2 minus x1 squared minus y2 minus y1 squared, plus, not minus. We plug in the points that we know here. So we're plugging in 3 and 0 for our x's. And we plug in square root of 7 and 0 for the y. And this is going to tell us the radius. So 3 squared is 9. Square root of 7 squared is 7. So that's square root of 16, which is 4. So the radius is 4. Which means the equation of our circle using the center and the radius would be x minus 0, y minus 0 equals r squared. So 4 squared, that's going to be 16. So there's the equation of our circle. We want to know if this point for negative 4 comma 0 is on that circle. If it is, we plug it in, it's going to be true. It will work out. The equation will work out. Both sides will equal the same thing. So we're going to plug in the negative 4 for the x, and we're going to plug in 0 for y, and see if we get 16. Essentially, you're just seeing if from 0, 0 to the first point has the same radius as 0, 0 to this other point. So plug in negative 4, plug in 0, check to see if that's true. Negative 4 squared is 16 plus 0. Yes, 16 equals 16. So that's true. It does contain the point. The circle does contain the point negative 4, 0. So you just need to know the radius and then see if it has the same radius, or plug it in to see if it's true when you plug it into the equation. So here we've got our center and the point 1 square root of 7. So we're going to first find the radius of the circle. Square root x minus x, so 1 minus negative 1. Y minus y. So that's 4 plus 6. So the radius is square root of 10. So our circle has an equation, x minus the center, x minus -1, plus y minus the center, 0, equals r squared. This is r, so square root of 10, you can just get 10. That's our circle. It has a center of -1, 0, and a radius square root of 10. We just need to see now if the point -1, 3 fits in that circle. So we plug in -1 for x. And we plug in the 3 for y. And check to see if it's true, if it equals 10. So -1 plus 1 is 0. 3 minus 0 is 3. And then we have to square that, we get 9. That's not true. 0 plus 9 does not equal 10. So no, it doesn't contain that point. Close, but not quite. So now we're going to check this point centered at the origin. Remember, origin means 0, 0. So we're going to find our radius. It is square root of 18 minus 0 squared plus -4 minus 0 squared. So that's square root of 18 squared is 18. -4 squared is 16. So square root of 34 is our radius. So that means the equation of our circle is x minus the center, so minus 0, plus y minus the center, 0, equals r squared. Square root squared is just the number. So now that we know the circle, we check the point 6, 0 and see if it's in there. Plug in 6, plug in 0. So you get 6 squared plus 0 squared. That's 36, which is not the same as 34, so no, that point is not on the circle. Almost the same question we've been dealing with. We have the point and the center, so we're going to find the radius. So we take 4 minus 1. And then -4 minus 0. So that's 9 plus 16. So the square root of 25 is 5, so our radius is 5. So the equation of our circle, x minus h, so x minus 1 squared, plus y minus k, which is 0, equals r squared. Take those points, 1, 5, those numbers, plug them in for x and y. Plug in 5. And this needs to work out to be 25 if that point is on the circle. So we have 0 squared plus 5 squared. Yeah, that's true. Yes, the 0.15 is on the circle. So this question's pretty similar, yet we have to work it out a little bit different. We know the center and the radius, which means we know the equation of the circle. So let's write the equation of the circle. X minus 2, y minus negative 2, so y plus 2, equals radius squared, so 5 squared is 25. And then we need to find two values of x such that x comma negative 5 is on the circle. So that means we're plugging in. It's kind of like when we were testing to see if this point was on the circle, we plug it in. We're doing the exact same thing, but we're going to keep x in the equation. So we're plugging in x for x, or we're keeping x where x was. But we plug in the negative 5 for the y. And then we need to solve this. So we can deal with the numbers. We're going to keep this whole x minus 2 squared thing by itself for right now. Negative 5 plus 2 is negative 3 squared. Equals 25. Negative 3 squared is 9. So we're going to subtract that 9. Subtract the 9, you get 16. So to solve this, since we have a squared around our x, we're going to square root. But something that you need to make sure you remember is when you square root an equation, your answer is plus or minus. Because when you square root 16, we get 4. But 4 times 4 is 16, but so is negative 4 times negative 4. So it could be a positive 4, or it could be a negative 4. Both of those are correct. 4 squared is 16. Negative 4 squared is also 16. So we square rooted to get this x minus 2 by itself, but it creates two really simple equations, one with a positive 4 and one with a negative 4. So to solve this, you just have to solve both of them because it does say two values of x. That's your hint about the plus or minus. So we're going to add 2 to the 4. So we got x equals 6. And we're going to add 2 to negative 4, and we get x equals negative 2. There's our two values of x. This is really the same question as what we were doing on the last page. We're checking to see if a point is on the circle. the point of tangency is just a point on the circle. So you're checking to see if the point 43 is on which of these equations. Choose all that apply. So it could be more than one, could even be all four of them. So if the point 43 is a point of tangency, that means you plug it in, you get something true. So when we plug in 4 and we plug in 3, it needs to equal 25. So plug in 4 and plug in 3. That's 4 minus 4 is 0 squared. 3 minus 3 is 0 squared. 0 does not equal 25, so no, that's false. That is not a point on that circle. Do the same thing for the next one. Plug in 4, plug in 3. 4 minus 1, that's 3. 3 plus 1 is 4. 3 squared is 9. 4 squared is 16. 9 plus 16 does equal 25, that's true. Same thing, we're plugging in 4 for x, 3 for y. 4 squared is 16. 3 squared is 9. Same thing, 16 plus 9, 25, true. Plug in 4, plug in 3. 4 plus 1 is 5. 3 minus 3 is 0. 5 squared plus 0 equals 25. That's also true. So we had three circles that contain that point, or it's a point of tangency. So these are related to what we were doing. They're slightly different. Here they give us a circle. They give us the center and another point on that circle. And then circle B has this center and another point on the circle. And we want to know if the circles are congruent. Congruent means they have the same size. The only thing that determines the size of a circle is the radius. So if they have the same radius, then they have the same size, which means they're congruent. So if they are congruent, they have to have the same radius. That's what we are checking. And we were solving for radius back here. The very first thing we did is we had the center and a point. We were finding the radius. So we're doing distance formula 2 times to get the radius. So we're going to do it for circle A. We're going to get the radius, which you take just the distance between the center and the point. So you do distance formula, 0 minus 0, and 0 minus 10. So that's 0 squared plus 10 squared. So the square root of 100 is 10. So the radius for circle A is 10. R equals 10. You could have probably figured that out just by thinking and looking at those points too. We're going to do the same thing for circle B. Find the radius between those points. -4 to 2, so -4 minus 2 squared. And then 6 minus -2. So that's -6 squared, which is 36. And then that's 8 squared, which is 64. Square root of 100, which is 10. So the radius is 10. So, yes, the circles are congruent because they have the same radius. So how to determine if circles are congruent? Find the radius by using distance formula. Find the radius by doing distance formula. Same radius equals congruent. So here we have a circle with center -1, 3, and a diameter of 6. So if the diameter is 6, that means the radius is half of that, so the radius is 3. Then we have another circle that has a center of, change the sign, you get 1, change the sign, -2, and the radius, r squared is 36, so r is 6. So we need to figure out the transformations that are going to map the first circle, -1, 3 with a radius of 3, onto this circle, 1, -2 with a radius of 6. So the radius gets larger, which means we're going to have to dilate it, and it moves, which means we're going to have to do a translation. We have to shift it and we have to dilate it. We have to shift the point from -1, 3 to +1, -2. How do you get from -1, 3 to +1, -2? To go from -1 to +1, you have to add 2. To get from 3 to -2, you have to subtract 5. So you could write it as a coordinate, x, y. Here's your rule. X, y goes to x plus 2, y minus 5. Or if you remember back to translations specifically, you could say it's the translate along the vector 2, -5. Either of those is fine for saying how to translate it. So that's the translation. You go 2 to the right and down 5. The dilation, we have to change the radius from 3 to 6. To change the radius from 3 to 6, you have to multiply by 2. So you have to dilate with a scale factor 2. You translate along the vector 2, -5, and then dilate with a scale factor of 2, and then they match up. This next question is just different wording for really the same thing. State the necessary transformations. Move from circle X to circle Y and show that the circles are similar. So the center has to go from -2, 3 to +3, 1. So from -2 to 3, we have to add how much? 5. And from 3 to 1, you have to subtract 2. So we translate along that vector. 5, -2. 5 to the right, down 2. And then you need to dilate with a scale factor to go from 10 to 5. It's getting smaller, so it's going to be a fraction. From 10 to 5, you have to divide by 2. So the scale factor is 1/2. As always with scale factors, you can always do the image over the pre-image. Image would be 5. The pre-image before we did anything was 10, and then you just reduce that to get your scale factor. If you can't come up with it, you can figure it out that way. So they are similar because we can translate and dilate and make them match up.